The OSI model stands for Open System Interconnect, and it was formalized by the International Organization for Standardization in 1984. OSI defines and uses to understand how data is transferred from one computer to another using a computer network. Networking is complex, so OSI model divides the complex functions of computer network to 7 layers. So to easily understand the system, let's make an example of a pizza company. They have 3 kinds of people: a receptionist to confirm the order, a chef to make a pizza, and a pizza delivery guy. A 3-layered process with each layer has defined inputs and outputs. The receptionist gets the order. He forms an order through call and passes it to the chef to make the pizza and provides it to the delivery guy, which he delivers to the customer. Take a look. If the employees of pizza companies do all these functions by themselves, then confirming their order, then baking the pizza, and home delivery. So it is why layered architecture is important to understand. Let's look at the benefits of layered architecture. The overall speed increases if you are a different kind of position. The quality of specific portion of a complex system can easily be discussed. Each layer acts as a separate module and is self-contained, so implementation changes in one layer and doesn't affect others as long as the input and output to the layer is the same. Example, by changing your chef or recipe of the pizza will not affect the delivery guy and the receptionist as long as the chef is receiving the order from the receptionist and providing pizza to the delivery guy. Imagine how difficult it would be to explain networking as a single unit without layered architecture. It will only result in chaos. So ISO proposed a 7-layer reference model for networking. Before going to more technical terms, let's explain it with a real-life scenario to understand it easily. It is titled King's Meeting. Let's start. The King of Spain wants to send an invitation message to the King of England. The King of Spain will not send this invitation to King of England by himself, so he will call his minister and dictate him the message with the details, including the agenda of the meeting, economic issue, and security concerns, and many more in Spanish language. The minister will write down all the details and convert the Spanish language to English language to understand it when the message is in British Palace. Then he will encrypt the letter to maintain secrecy and compress the content as much as possible for easiest delivery. The minister himself is a very high post, so he also calls his secretary and passes on his work. Secretary knew the importance of the letter, so he called the British Palace and told the secretary that he will send a very important letter. So please let us know as soon as you receive that and then start the session, and the secretary will agree on this. Now, the secretary will pass the letter to the coordinator and ask him to attach the further details to this letter and send it. The coordinator will break down this larger letter through smaller chunks and attach sequence, number for the identification of order, and write down the name of the intended receiver at the British Palace on this letter. Till now is moving around at Spain Palace. After all these pre-processing letters are finally moved to transport officer, so he can decide a mechanism to move this letter out of Palace. Transport officer will decide the route that should be followed and write down the address of Spain Palace on the letter and call one of his drivers and tell him to the route to follow and pass him the letter. Driver is now responsible for error-free delivery of this letter. This driver is assigned to deliver letters to just specific points, not at the ultimate and to the British Palace. The next driver will now choose a vehicle and put his a letter on it and deliver it to the next transport officer. This transport officer will decide the next route to destination and call one of his driver and pass the letter to him. The driver will choose a vehicle and put this letter on it the same. And after maybe 3 or more transport officer, the letter will finally reach the British Palace. The intended receiver at the palace will be combining the letter using a sequence number and made them a single unit, and he'll pass them to secretary so that he will give to the minister, because he himself is not authorized to meet the king. The minister will receive the letter, and when confirmed that it is written in English language, the minister then will decrypt and decompress the letter. Once all done, he'll provide the letter to the king, and it is important to remember the whole process of letter transmission because you will understand how the OSI model works in networking. So assume that king heard a powerful technology called the internet. Now let's compare the processes of real life and how it will change in OSI model. The first layer of OSI model is application layer, in which the user interacts directly with network-aware applications like browser or teleconferencing apps. If the developers of these applications would have to control all hardware communications, bits, current, circuits, and etc., it would take a lifetime for developers to build a single app. So developers only write the business logic of applications, and for all network-related functionalities, applications request network layer protocol, for example, FTP or file sharing, HTTP for web, and SMTP for mail transmission. The second layer of OSI model is the presentation layer, in which the minister changes the language format, that is Spanish to English, encrypts the address of British Palace and the route that should be followed. Transport officer is not responsible for physical delivery. He is only a decision maker in the network layer of OSI model. IP address of destination computer is attached to the segment received from the transport layer, and the route is decided to which should be forwarded. There are two kinds of protocols in this layer: routed protocols and routing protocol. Routing protocols actually find out the shortest path from source to destination, and routed protocol, for example, IP is used to send the data from source to destination, and the device is used to communicate among networks, is called a router. The next step, driver. The driver received this letter from the transport officer and said that the letter should be safely delivered to the next person in the data link layer of OSI model. There are further two layers, logical link layer and media access layer. Logical link layer is responsible for error-free delivery of the message, and media access layer ensures that the transmission media is free to send our data, the source MAC address and destination MAC address will be added to the packet that had been received from the network layer. The last layer is actually the vehicle, that is the car past the plane used to reach the destination. Same like that in the OSI model, the physical layer is actually the transmission media that had been used, for example, a coaxial cable, Ethernet cable, fiber optics, or a wireless media. This is the summary of the whole OSI model. We start at the bottom. Physical layer is actually the hardware or the transmission media. The data link layer is responsible for link-to-link delivery that is delivered inside the lab. The device used here is a switch. The third layer, network layer, is responsible for end-to-end delivery of the message. That is from the very initial source to the very last destination. The device used here is the router. The fourth layer is the transport layer. It is responsible for application to application delivery. For example, the browser to browser. The browser in the sender's PC to the browser in the receiver's PC. The next layer is the session layer. It is responsible for creation of sessions. For example, in Facebook, you must not have to authenticate yourself for each packet that you are sending to the Facebook server. The second layer is called the presentation layer, which is responsible for format conversion, encrypt, and compression. The last layer is application layer. It contains application protocols, for example, HTTP, FTP, and SMTP, that helps network-aware applications to communicate over the network.